no changes whatsoever. So y equals x raised to 1 over x. Step 2, natural log y, 1 over x times natural log x. Step 3, we apply the limit to both sides. So this is just routine now, right? Once we understand this, so limit as x approaches infinity from natural log y equals limit as x approaches infinity from natural log x over x. Music to my ears, because it's infinity over infinity. So limit as x approaches infinity, the top prime is 1 over x, the denominator prime is 1, and this is equal to what? Very good. So now in step 4, I copy the beginning and the end. So I have the limit as x approaches infinity from natural log y equals 0. But what I'm really interested in is limit as x approaches infinity from the function x raised to 1 over x after I swap the operators. So what do I get? Yep, it's e to 0. And then some of my students in the past, when we got to something like this, they said, see, I told you, infinity raised to 0 will be 1. No. No, do not conclude any of that. It's an indeterminate case. The answer can be anything. Okay, so finally, with all that being said, we're going to just continue graphing. We're going to choose anything you want, and now we have all the information for graphing. And what is left from this chapter? Number 1, optimization, another application of differentiation. And number 2, Newton's method. So definitely by Tuesday, you must finish 4.1 through 4.5 with at least 60%, which is really half of it, please, so you can ask all possible questions. And then we're going to finish these two.
About Tuesday and next week?
Yes.
Talk about Thursday. Okay.
By Tuesday, definitely. By Thursday, Tuesday next week, yes. So, so I would do definitely half by Thursday and the other half the rest, because we're going to probably just quickly finish these two in the next 2 sessions, so we can schedule test 3, because we have still a lot of work and I have to review for the final, so still a lot of work ahead of us. So at least by next week, a week from today, this should be finished with 60%, please, so we don't scramble at the end before a test. Okay, so let me share my screen. I'm going back to the next section. Where are you guys? I see you. Okay. With all the windows open up, I kind of lose you sometimes. Okay. I do not cover 4.6. Look at it, see if there is anything that you would like to discuss. This is just using technology. We're using technology all the time. So, okay, so we have optimization problems and Newton's method. 4.9 will be paired with test 4 with chapter 5. So 4.9 will not be part of test 3. Okay, so we are here, summary of curve sketching. So choose any function that fancy your eyes. Anything, anything, anything. Okay, so just name a function, choose a function, and we'll work on it.
14.
14. 1 over x squared minus 4. This one?
I pulled that number out of random. Is it good for this concept?
Anything is good. A rational or product or anything.
Let's do 14 first, 'cause it's
Okay, very good. So let's start with 14. And that is y equals 1 over x squared minus 4. Good. So the problem is asking us to do everything. Everything that we studied, fill up the table, summarize the information, and then graph. Okay. So, of course, my starting point is to work on the function and realize that the denominator is factorable and find its domain immediately. So, can anyone help with that?
It's x plus 2, x minus 2.
Thank you.
And
So-
x cannot be 2 or negative 2.
Excellent. So that's our starting point at any time we graph a function. And then I get my table going. Please, I'm begging you, summarize the information so you can graph. The reason why I prefer the function in the middle is because I can look up and down. If I put the function in the middle, at the top, and the derivative at the bottom, then I have to look just underneath and I may lose something, I may miss something. Okay, so I have negative infinity to infinity, I have 0 in the middle, I have negative 2, I have 2. If the function is undefined, its derivatives will be undefined there as well. So one more time, I'm going to write the function here as 1 over x squared minus 4, 1x plus 2x minus 2. The factors stay, so they will not go away, they will not be simplified. It's not going to be a hole in the graph. So then x equals negative 2 is a vertical asymptote, and x equals 2 is also a vertical asymptote. I always start with the function. I determine x and y intercepts, limits, asymptotes, etc., and only then I go to the first derivative, and only then I go to the second derivative after that. Good. So now I have to determine this, and this. And also plug in 0. When I plug in 0, what do I get? Negative 1 over 4. Perfect. Okay, so now let's find these limits. So limit as x approaches negative infinity from 1 over x squared minus 4. Can anyone give us this? Limit as x approaches infinity from 1 over x squared minus 4. And then limit as x approaches negative 2 from the left. Negative 2 from the right, and limit as x approaches 2 from the left, and limit as x approaches 2 from the right. Good. So can anyone give us this?
It's going to be 1 over minus infinity.
Which is?
Beginning?
0.
Thank you. And what about this?
Also 0.
Of course, which means 0 and 0, which means y equals 0 horizontal asymptote. Perfect. What about this?
1 over negative 4. Actually, 1 over 4.
The numerator is 1 and the denominator is 0. We're talking about vertical asymptotes. You can never give me a number, right? We're talking about vertical asymptotes. So we cannot get a number here. It's not possible. So negative 2 from the left. This is a negative number and this is a negative number. So what do I get?
Infinity.
Thank you. What about here? Negative 2 from the right. Like negative 1.9. This is positive and this is negative. The top is 1, the bottom is 0.
Negative infinity.
Negative infinity. So this is positive infinity and this is negative infinity. What about here?
I mean negative infinity.
So 2 from the left is 1.9 and this is positive and this is negative, negative infinity. And 2 from the right is 2.1, so positive, positive, so it's positive.
Infinity. Yes.
Good. So negative infinity and infinity. This is it. We exhausted the function. There is nothing else we can learn from the function, about the function, from the function about itself. Okay. Now in the next step, we're going to look at the first derivative. But I would rewrite the function, but that's my preference. Because the numerator is a constant, why would I bother with the quotient rule? But it's up to you. It doesn't matter. So f prime of x is negative x squared minus 4 to negative 2, but times the inner function, which is 2x. Of course, inner function prime I meant. So negative 2x over x squared minus 4 squared. So can f prime be 0 for critical numbers? Anyone? So can f prime be 0? Trey, I haven't heard from you yet. Can f prime be 0? Trey, are you with us?
F prime 0, that is a critical number. I think that's where it happens, right?
Right, but what is x? So can f prime be 0? Yeah. Anyone?
It's going to be 0 equal to the equation, like negative 2x x squared. Or you can write like the x squared minus 4 squared equal to negative 2x.
When is a fraction 0? Anyone? Good. So then x equals? Thank you. So it's the only critical number when x equals 0. We are not going to plug in anything in x squared minus 4 squared because this is always positive. But I need the sign to the left of 0 and the sign to the right of 0, of negative 2x. So what is the sign to the left of 0?
Positive.
Very good. What is the sign to the right of 0 of the entire derivative?
Negative.
Very good. Awesome. At this moment, I test my work. If these two rows do not work well together, if they don't go in sync, then I'll say, back to the drawing board. Something is terribly wrong. So from 0 to infinity, what does the function do?
Increases.
Yes, is that correct?
Yes.
Perfect. From negative infinity to negative 4, what does the function do?
Increases.
Is that correct?
Yes.
Perfect. From negative 1/4 to negative infinity, what does the function do?
Decreases.
Decreases. Is that supported by the sign?
Yes.
Yes. And from infinity to 0, what does the function do?
Decreases.
Is that correct?
Yes.
Okay, a sigh of relief, because these two work in sync. I checked, everything is perfect. Okay, at this point, I have to take this, differentiate it again to find the second derivative. And then, once I fill in this piece, I'm done, I can graph. Okay, so the second derivative, I recommend leave the -2 outside, waiting patiently. The top prime is 1, x squared minus 4 squared, minus the top, times the denominator prime, 2, x squared minus 4, to 2 minus 1, times 2x, divided by the denominator squared. I want to caution you again, I cannot give credit for a problem if somebody does this, simplifies an x squared minus 4 from the top with an x squared minus 4 from the denominator before factoring, and not factoring from both terms. Please, I'm begging you. I don't mind begging my students. I've been doing it for more than 20 years. So the numerator has an x squared minus 4 in common, then an x squared minus 4 to the 4th, and after that I can do this. Yes, I'm allowed to do that. So what is left from the top? An x squared minus 4. This is gone. So I have 2x times 2x, which is 4x squared with minus in front. Are we okay so far? Is this okay?
Yes.
Okay, perfect. So then I continue. I have still a -2. So negative 4x squared with x squared will be negative 3x squared and minus 4 at the top. The denominator is x squared minus 4 to the 3rd. Of course, I will factor out a -1 that will eliminate this. So this is 2, 3x squared plus 4, divided by x squared minus 4. I'm going to write it like this, times x squared minus 4 squared. And you can say, what is this? What are you doing? Why don't you write power 3? Because I want you to realize that this piece, don't cross it out, all this piece is always positive. So you don't have to study, I meant this, of course. You don't have to study the sign of that piece. But you do have to study the sign of this piece. So in other words, all this is a positive number. So this will never be 0, no matter what you do. The numerator is always positive. So there are no inflection points, obviously, because the function, the derivative, the second derivative is never 0. And the sign will be given by this. So tell me, what will the sign be here? Plug in a number to the left of -2, plug in 0 and tell me the sign, plug in 10 and give me the sign. Not all this. It's a waste of time to even look at that. It's all positive. So, what do I write outside? What do I write inside? Anyone?
It should be on the left, negative. -2 should be positive.
So when I plug in 0, this must be negative. There is no discussion there, right? So when I plug in anything here, it will be positive. Is that okay with everyone? Yes? No?
Yes.
Okay. Very good. So I don't need anything else. All the rest of the information is not important to me. Everything is in the table. So I'm going to graph the function. Everything else is noise. Everything that I need is right here. I start with 2 vertical asymptotes. One thing that I forgot to mention is the symmetry. I'm going to do that in a second. Let me just put the... So the function has x equals -2 and x equals 2, and also has, this is an overkill, there is no need for this because it's the x-axis, y equals 0 horizontal asymptote. So let me just talk about the symmetry. So f of negative x is, where's my function? F of negative x will not change the function. When I replace x by negative x, the whole thing stays as is. So that equals f of x, which means it's an even function, which means symmetric, with respect to the y-axis. So I will make sure that that's going to happen. Okay, so now it's coming from the horizontal asymptote going to infinity, always increasing, opening up. It will be opening down, coming from negative infinity, crossing at 0, negative 1/4, and going back to negative infinity, increasing. So of course this is a relative max. The signs positive, 0, negative gives us a relative max. Max from negative infinity to negative infinity. So, and symmetric of course with respect to the y-axis. On the other side, it's coming from positive infinity, increasing to 0, opening up. Very clear. I didn't need to look at the other side. It has to be symmetric. It has to be symmetric with respect to y equals x. With respect to the y-axis. It has to be a complete symmetry because the function is even. So that's it. So this is f of x equals 1 over x squared minus 4.